so far we learned rules that we will follow, but the rule that I am about to teach you is a beautiful rule which we will use most often in solving problems in differentiation. So if I give you the function f of x, and the function is say sine of x squared. I give you x squared, I give you sine, and I combine it, so it is sine of x squared. Now you are a bit confused when I ask you the derivative of this function. So you are a bit confused. I know the derivative of sine x, I know the derivative of x squared, but this function is a little bit confusing. So what is the derivative of this function? Let's see, let's look at it with a different perspective. I'm not trying to prove anything, I'm just showing to you things that are with a different perspective, a different point of view. So let's say we substitute x squared as u, we equate x squared as u. So and we have du by dx. So this is du by dx. So what will be du by dx? As we say, x squared is u, so u is x squared. So du by dx is nothing but dx squared by dx. That is the derivative of x squared, which will be 2x. So let's name this as the equation 1, because we have to use it again later on. So I have this, and instead of writing dy by dx, I have one more variable now, so I'll use dy by du into dy by dx. So this is not a rocket science, this is a very familiar thing. So you are just instead of differentiating it once, we are just differentiating it twice. So this is with respect to du, and this is with respect to dx. The with respect changes, so the perspective is changing. So instead of writing it in this way, we are writing it in this manner. We are just uh, expanding it. Yeah, this is the right word, we are just expanding it. So what is du? It is x squared, but let's forget it for a minute. Let's have it. So d of y. So what is y? Y is sine x squared. Sine of, wait a minute, x squared is u, as we have mentioned here. So x squared is u, so we can write it as sine u. Sorry, so we can write it as sine u with respect to u into du by dx. Does something look familiar with you? Yeah, something looks familiar. In equation 1 we proved that du by dx is just 2x. So it's made simple. D of sine u with respect to du into 2x, because du by dx is just 2x. We are substituting equation 1 here. So what was dy by dx, which is here? So dy by dx was just the derivative of a function, say f of x. So it was f prime of x. So now this function will be also f prime of x, because this is same as this but a different perspective. So what is d sine u by du? There's just a difference of x. Instead of d sine x by dx, there is just a difference in the name of the variable. So this will be same as cos x. So this will be the derivative of sine x, which is cos x, but instead of x we will write u. So the answer for this will be cos of u into 2x. Now what was u? It was x squared. So effectively the answer will become cos of x squared into 2x, and this is the answer for the derivative of sine x square. This is a very beautiful rule. This rule is called the chain rule. It can be used in various this rule increases the domain of the things that we can solve, the derivatives of things we can evaluate exponentially. So from 1 it becomes 2. So it is a very beautiful function. So it is widely used. You will often use it in many sums. It is most widely used in differentiation. So if you have, the rule says that if you have a function which is a combination of two differentiable functions, then you just take one function, the inner function, as some variable, you substitute it, and then you find the derivative of that. So it says that dy by dx is not, it can be written as dy by du into du by dx. That's all the function says. So this can be done n number of times. Even if we have say sine of e raised to x the whole squared. So this can be written as say you can take u, you can take y. So you can take this whole thing, sine of e raised to x. You can take sine of e raised to x as y. Let's take it to the other page. So you can take let me bring the function again, sine of e raised to x. This is the function which is whole squared. So this is f of x again, and they have asked you the derivative of that. So what will be that? So you can just equate it with y. So y is sine of e raised to x, and say u is e raised to x. So that does a lot of work for us, saves a lot of work for us. So instead of writing y, let's just take it as say w, because y, we already use y in the differentiation notation, which is dy by dx, where we use y. So let's just write w. So w's value is sine of e raised to x. So what is sine of e raised to x? That is d of w by d of u. It is nothing but sine of e raised to x by uh, d of sine of e raised to x by d of e raised to x. So it will be nothing but say uh, first we let's just take u first. So instead of taking this first, sorry for the inconvenience, yeah, so let's just take u first. So let's just derivate u first. So let's take du by dx. So what is the du by dx? So it is d e raised to x by dx. So it is just e raised to x, because e raised to x remains e raised to x even after derivating. So this is e raised to x. Let's just take it as equation 1. Next we have w. So d of w by d of u. So let's just have a different perspective for this. We'll have a different perspective for this too. So d by d of w by d of u is nothing but sine of e raised to x by d of e raised to x. So e raised to x is u. So this is d of sine u by d of u. So what will be this? This will be just cos x, because the derivative of sin x is cos x, but instead of x we are writing u. And what is u again? U is just e raised to x. So it will be e raised to x. So the derivative of this function right here will be dy by dx of f of x will be dy by dw into dw by du into du by dx. So this will be equal to this, and that makes a lot of work easier. So dy by dw, what is dy by dw? So dy by dw is nothing but sine. What is dw? It is just sine of e raised to x. So what is y? What is the y? It is sine of e raised to x the whole squared. So let's just take all of this part as some variable s. So this part, instead of taking it as, we have already defined it as w. So this will be the y value. The y here is sine of the it will be w squared, d of w squared by d of w. Yeah, so this will be d of w squared by d of w, which is just 2w. So what is w? We'll substitute it again afterwards. Then we move on to dw by du. So what is dw by du? What is dw? So d of w, dw is just sine of e raised to x. So we can write it as a sine of, what is e raised to x? It is u, sine of u by d of u. So we are differentiating it, and we find that it becomes cos of u, because the derivative of sine of x is cos x, so it becomes sine of u. So it is multiplied by the final answer. This becomes the final answer, is multiplied by cos of u into, what is the du by dx? So what is du by dx? So what is du? What is du? It is d e raised to x by dx. So what is d e raised to x by dx? Yeah, it is just e raised to x. So this became so easy from a very complicated sum. So we have to just substitute the things right here, which is 2 of sine, instead of w we are writing sine of e raised to x. Then we'll be writing cos of u, which is e raised to x, into e raised to x. Yeah, let's just put it in bracket. So this was the chain rule and sum for an example.